All right, good evening, everyone. We're on day two of our Kubernetes week. Yesterday, for day one, you guys just had a quick introduction on Kubernetes. Today, we're going to be diving a little bit deeper, getting into deployments, replica sets, and services. So we have one lesson today, one lab, and we also have a challenge. So for our challenge, we actually have I think five different ones. So they range in difficulty. So the first three are easier, and then this gets a little bit more difficult, and then this is the most difficult one for challenge five. So just at the end of the lecture, just work through that. But let's go back to our outline. We have our TLOs and ELOs. So today is about putting the pieces together. Now that you understand containers and basic Kubernetes concepts, you'll learn how to compose them into production-ready applications using deployments, replica sets, and services. Before we actually get into the lesson, I just want to talk about the difference between the three. So think of Kubernetes as a factory system, and a pod is a worker on the floor doing its job. So a deployment is like the factory manager who says we need five workers building widgets and they should all follow this exact process. So it will decide how many pods or workers you want, defines what they look like. So that will be like choosing the container image or the config. Uh, Deployments also handle updates. So it says, hey, everyone switch to the new widget design. And deployments also handle rollback if something goes wrong. Now, a replica set is more so the floor supervisor hired by that manager. So replica sets make sure exactly five pods or workers exist. If one worker quits, they hire a new one. If there's too many, they fire extras. And then a service is like the reception desk that will route customers to an available worker. So it gives a stable address, load balances traffic, and hides which specific pods are serving. And also keep in mind that pods are temporary, but services are stable. So we're going to be getting more into that and kind of reiterating the difference between each three within the lesson. So what are we trying to accomplish? We aim to extend your Kubernetes foundation with three essential capabilities: declarative application management, self-healing infrastructure, and network accessibility. By the end of this day, you will understand how to create deployments that automatically maintain your desired application state, how replica sets ensure your pods stay running even when failures occur, and how services expose your applications to the outside world. You'll build a complete application stack that self-heals, performs rolling updates with zero downtime, and load balances traffic across replicas. So are there any questions before we get into the lesson? All right. So Kubernetes deployments, replica sets, and services. So an overview, Kubernetes becomes truly powerful when you understand how its core building blocks work together. Today, you'll learn how to create and manage deployments that automatically maintain your desired application state, understand how replica sets ensure your pods stay running, and expose your applications to the world using services. These three concepts, deployments, replica sets, and services, transform isolated containers into production-ready, scalable, and accessible applications. So why do deployments matter? In a production environment, you need guarantees that your application stays running. Manually managing individual pods is error-prone and doesn't scale. Deployments solve this by declaratively managing your application's lifecycle. We have an example here. It says, imagine running a restaurant where you need exactly three chefs in the kitchen at all times. Without a manager, if a chef gets sick, you'd have to notice, find a replacement, and train them yourself. A deployment is like a manager who automatically notices when a chef is missing and immediately brings in a trained replacement. No manual intervention required. So I know I mentioned that replica sets kind of uh, handle this role. So notices when a worker is missing and immediately brings in a trained replacement. But this example is also true because with that deployment, you're also creating a replica set. So that replica set will take care of that at the deeper level. So there are three approaches. So if you just do a manual pod management, so create and monitor pods yourself, there's a lower reliability, so it's more error prone, and there's no auto recovery. If you switch to a replica set only, uh, you'll have a higher reliability, so limited roll, but so you'll have a higher reliability, but there's a limited rollout control. And again, the replica set maintains pod count, uh, and there's no update strategy. For deployment, you'll manage your replica sets with rolling updates, and it's the highest reliability with production ready and self-healing. Any questions? How do deployments work? A deployment is a higher level abstraction that manages replica sets, which in turn manages pods. This hierarchy provides powerful features like rolling updates, rollbacks, and self-healing. The deployment hierarchy, so you create a deployment with a desired state, so image, the replicas, etc. The deployment creates a replica set to maintain the specified number of pods. Then the replica set also creates and monitors pods. If a pod fails, the replica set automatically creates a replacement. When you update the deployment, it creates a new replica set and gradually shifts traffic. So the key components so far that we spoke about are these three: deployment, replica set, and pod. Later, we'll get into the selector and template within the actual files. So deployment declares desired state and manages updates. Replica set ensures correct number of pod replicas. Runs your actual containers. Selector matches deployment to its pods via labels. And template defines the pod specifications. I'll get more into selectors and templates when we get into the files. So creating deployments with CLI, the fastest way to create a deployment, great for testing and learning. So if you just run this command, actually let's actually do it. Hold on. Let me pull it up on my other screen. So if we run this command, it will actually create a deployment using the Nginx image. And this is the name of that deployment. So Nginx deployment. So let's run this. Or actually, I think I have to do minikube start first. So this is just starting everything up so that we can work with Kubernetes locally. Any questions so far? So within the lesson, I'm just going to go through some of the commands. Most of everything we're going to be covering through the actual lab, but I feel like this one is an important one, so let's run it. So again, we're doing kubectl create deployment. We specify the deployment name, and then we specify the image of that deployment, and we're using Nginx. So let's go ahead and create it. We got a confirmation that it got created. So now let's do kubectl get deployment to see what deployments we have. And as we can see, we have that Nginx deployment that we just created. It is ready. So 1 out of 1. It's up to date and it's available. It also shows you the age of it. So we created it 13 seconds ago. Let's see if we got created any pods. So for this, we'll do a kubectl get pods. And we have one pod, which is also ready and running. There hasn't been a restart yet, and the age of this is 38 seconds. So notice how we have that deployment name, and then it just got tacked on with a random digits and letters at the end. Now let's do kubectl get replica set to see if we have any replica sets. And we do. So again, we have the name of the deployment with some random letters and numbers attached to it afterwards. So we didn't really specify, but within this command, it's just saying that we want one pod always running. And currently we do have that one pod and it is ready. And then the age of everything is 67 seconds. So if you notice as well, everything kind of, so you can do everything kind of has the same pattern or format. So you'll do for the different resources, you can do kubectl get deployment, get pods, get replica set. If you want to delete something, you'll do kubectl delete deployment, delete pods, delete replica set. So that's one pattern to it. Let's go back to the lesson. So the example says, think of these commands like checking different levels of an organization. So get deployment is like asking, is the department running? Get pods are the workers present? And get replica set is the team lead maintaining headcount. So we can also modify our deployments. So we can do that by running this command, kubectl edit deployment, nginx deployment, and it'll just run your default code editor. So let me quit out of that by doing :q. So that opened up that deployment configuration. So within there, you can change the image version, replica count. So we had one for the desired amount of pods that we want. So we could have changed it to 3. We can also change environment variables. When you save changes, Kubernetes performs a rolling update, creating new pods with the updated spec before terminating old ones. To monitor and debug, we can view logs from a specific pod. So we can do kubectl logs, and then we specify that pod name. So kubectl logs, and then this afterwards. We can also execute commands inside a running pod. So kubectl exec, give it the flag IT. So IT is for interactive. We specify the pod name, and then this is what we're running inside. And then we can also list all deployments again by kubectl get deployments. Cleanup, we can do kubectl delete deployment. So I'll just do that real quick. Kubectl delete deployment. And then we'll just specify the specific deployment we want to delete. And it got deleted. Let's actually check to see if we still have the deployments. So no resources found. And by deleting the deployment, it actually trickles down the hierarchy. So the pods will also get deleted, and then as well as the replica set. So again, the deployment is at the highest level. Understanding replica sets. A replica set ensures a specific number of identical pod replicas are running at all times. While deployments manage replica sets for you, understanding them helps you debug issues and grasp Kubernetes fundamentals. So why do replica sets exist? So let's look at 3 different scenarios. If a pod crashes, a manual restart would be required without a replica set. But if we had that replica set, it will be automatically replaced. If we needed to scale up, and we didn't have a replica set, we'll need to create the pods one by one. With the replica set, we just need to change the replica count. If there's a node failure without a replica set, pods are lost forever. With the replica set, pods are scheduled to healthy nodes. So within our example, it says a replica set is like a thermostat for your pods. You set the desired temperature, which in this example is the replica count, and it constantly monitors and adjusts to maintain the exact date or exact state, adding pods when there are too few and removing them when there are too many. So this example right here is just looking at a, re- a a file that is creating a replica set. Uh, so while deployments are preferred, here's how a standalone replica set looks. Let's take a look at this section right here. So this section over here is specifying the metadata for this replica set. So if we go to over here, this section is just specifying the how many replicas we want. So we want 2 pods always. And then the selector match labels, which is app nginx server, allows that replica set to find those pods. So it's saying look for these labels, or look for this label, app nginx server. Now the template is actually more so to do with your pods. So this metadata section is the metadata for your for each of your pod that gets created. So we have the notice how we have a label for those pods as well, app nginx server, and so that the replica set can communicate with it. And then this spec section is actually specifying the image for that container as well as the port. And this table just briefly just goes over it as well. So again, spec.replicas is for the desired number of pod copies. Spec.selector.match labels is how replica set finds its pods. Spec.metadata.labels is the labels applied to the created pods. And then spec.template.spec is the pod specification. And again, over here, just saying what I mentioned earlier, the match labels of the replica set and the label of the pods have to be the same so that they can communicate, or so that the pods can be found, is a better way to put it. So working with replica sets, so if we created a file called nginx replicaset.yaml and put this code in there, this is how we would create it. Then we can get the replica set, get the pods, and then filter out by labels. Kubernetes service, why service or Kubernetes services? So why does a service matter? Pods are ephemeral. They can be created, destroyed, and moved at any time. Their IP addresses change constantly. Services, however, provide a stable network endpoint that routes traffic to the right pods, regardless of their current state. So for an example, imagine a call center where agents or pods come and go throughout the day without a central phone number, so a service in this case. Customers would need to know each agent's direct line, which is impossible to maintain. A service is like the main phone number that automatically routes calls to available agents. So without services, we must track individual pod IPs. If a connection breaks or connections break when pods restart, there's no load balancing, and it's internal communication only. With services, there's a single stable IP or DNS name. There's automatic routing to healthy pods, built-in load distribution, and external access is possible. Service types, we have four: cluster IP, node port, load balancer, and external name. The three important ones that you guys really should know is the cluster IP, node port, and load balancer. Uh, when you're doing your capstone or assessment, you might run into some connectivity issues. So this is where you would first uh, go to check to see if maybe you had the wrong service type associated, and is the reason why maybe you can't get your pods to talk to one another, or uh, just for connectivity debugging. So let's look at each type. So cluster IP is an internal cluster IP. Accessibility is within the cluster only. Node port, static port on each node's IP. And then we have a load balancer. So cluster IP creates an internal IP address accessible only within the Kubernetes cluster. So other pods can call it, but external users cannot. So when you think about cluster IP, it's when you're trying to get the pods to be able to talk to one another. Think about how workers can call other workers, but someone outside the building can't. So also think about front end pod that is able to talk to the back end pod. Node port is like creating a side door with a specific door number or port. People outside can now reach the cluster, but they must know the building address. So in this case, the node IP and the door number, the node port. For load balancer, think about a company installing a professional front entrance with security and traffic control. So all services already load balance across pods, but the load balancer type controls how traffic enters the cluster. Imagine a big factory campus with three buildings, so three nodes. The external receptionist, which would be the load balancer, decides which building or node a visitor enters. Once inside the campus, there is a central receptionist, so the service, who runs the visit, who routes the visitor to an available worker or pod, regardless of which building they're in. And then external name just lets a worker reach someone or something outside the factory through a domain name. I'm gonna keep on going. So deploying a complete application. Now let's put everything together. Deployment managed by a service. So step one, we're going to create a deployment manifest. So just like earlier, this section right here is specifying the actual metadata for that deployment. So the name is Nginx deployment. And then we have the labels app Nginx dep. And then this kind of looks like what we did for when we were creating a replica set. So we want one pod at all times. We're looking for pods that have the Nginx via deployment label. And then for our template, we're specifying the labels of each of that pod, or however many pods it creates. And down here, we're just specifying the image and the ports of the container. So that would be one file. So this includes pretty much the deployment and the replica set. We would have a separate service file. So this right here is specifying the metadata for that service. So we have the name Nginx service. We have our specs. So we have a selector of Nginx via dep, and then we're specifying our node type and then our ports. So we have a protocol of TCP port 80, target port 80, and node port 30,003. Notice the services selector app matches the deployments uh, label as well. This is how the service knows which pods to route traffic to. So this part right here, the spec dot selector, just allows you to connect back to that deployment because it has the same label. So understanding the port configuration, notice how we have port, target port, and node port here. So port is what the pods talk to in order to reach the service. So it's where the workers can reach the receptionist. Target port is how the service can reach the pod or how the receptionist can reach the worker's phone/desk. Node port is the door that external traffic can reach to get to the receptionist. Another example is think of it like a hotel. Node port is the main entrance address. So it's how external traffic can get to that hotel. Port is the front desk. So how external traffic and whoever's staying at that hotel can uh, reach wherever they need to, maybe ask questions on how they can get to the restaurant or something. And then target port is the actual room where the guest, so your app is staying. So I mentioned this will be one file, and then this would be another. So your deployment and service. To create both resources, you would just do kubectl apply -f deployment.yaml, and then kubectl apply -f service.yaml. And then to get the accessible URL, you would just run minikube service and specify the service and get the URL. Traffic flow architecture, understand how traffic flows through these components. So if we have an external request, it goes to that node port, and then it goes to the service. It will then load balance across to the different pods, and that pod will have a container. The service acts as an intelligent router. It receives traffic, health checks, available pods, and distributes requests across healthy replicas. Here we just have some CLI commands. So this command is for quick deployment creation, which I showed you guys earlier. This is how you list all deployments, how you modify deployment config, remove deployment and its resources, roll back to previous version, and check rollout progress. For pods, we have list all pods, filter pods by label, view pod logs, shell into the pod, and detailed pod info. Services, we have list all services, detailed service info, and get external URL. What are the best practices? Use deployments, not replica sets. Label everything consistently. Start with cluster IP. Just think about security. Use meaningful names. Declare resource limits. Use readiness probes. So in summary, we went over deployment, replica set, service. We didn't really go too much. Well, labels, we went through what they are within the file. So those are pretty much used to connect your deployments to replica sets, to pods. And we also went over service types. Here's a quick reference, imperative versus declarative. So imperative, kubectl create deployment. It's quick for testing. It has limited options and is hard to reproduce. Declarative, so using a file, is version controllable, full configuration access. reproducible, and auditable. So use imperative commands for quick tests and learning. So that was what I showed you guys on the terminal, just quickly creating a deployment. And then use declarative manifest for anything you want to keep, share, or deploy to production. So that's actually creating that file so you can have more control over it. Uh, so just going through this again, uh, the main material that you guys should know is what a deployment is, what a replica set is, and what a service is, and the distinction between those three. Study up and learn the different node types, and then or the service types, I mean, as well as the ports, because you, you guys will most likely run into some connection issues between all of them. So just make sure you have a good grasp on the different types and the ports so that your pods can communicate with each other. So are there any questions? All right, let's go to the lab. Let me pull it up on my other screen as well. All right. This lab teaches you to deploy and manage applications in Kubernetes using both CLI commands and manifest files. You learn how to create self-healing deployments, understand the replica set abstraction, and expose your applications to the outside world using services. Objectives: by completing this lab, you will create and manage deployments using kubectl CLI, understand how deployment, replica sets, and pods relate to each other, modify running deployments and observe rolling updates, create a standalone replica set from a manifest file, deploy an application using a deployment manifest, expose your application using a node port service, and access your running application from outside the cluster. So first thing we want to do, which I already did, was do minikube start, just so you can start everything up. So go ahead and do that. Next thing we're going to run is kubectl cluster info, and we should see an input or an output showing the Kubernetes control plane address. So over here. And then let's just go ahead and check that there are no deployments, pods, or services, or see what we have. So we have no deployments, we have no pods, we do have a service, but this is fine to be there. This is just part of Kubernetes main service. So that's the API server. So we're on step 2. Let's create an nginx deployment using the imperative command. So we're creating a deployment called nginx deployment, same as earlier, using the image nginx. This will create a replica set and create a pod automatically. Let's run this. Let's get the deployment. So we have one ready and it's up to date, available with an age of 5 seconds. Let's check our pods again. So we have that deployment name with the extra digits and letters. It is ready, running, and hasn't been restarted at all with the age of 16 seconds. So one thing I also want to say is whenever you have more complicated pods, so if you have a front end, back end, and uh and a database maybe, they will kind of depend on each other. So you also have to set it up in a way where one pod will start first. So you'll probably have your database started first, then you would have your back end, and then finally your front end. So right now it says we see that it's always ready, but when you're actually building that production ready application, these all could be different uh, in regards to the ready status, or yeah, ready status and the actual status of it, and maybe restarts. So let's get our replica set. So deployment name with that extra characters added on. So we didn't have much control over this imperative way of creating that deployment. So we only have one desired pod. We do have that pod as we saw earlier, and it is ready. It shows the age of this specific deployment, but everything kind of was quick to be made. So everything is probably at 90 seconds as well. So let's actually get detailed information about our deployment. In order to do that, you would do kubectl describe deployment. Remember how I was saying you can, you have like kubectl uh, get deployment, kubectl delete deployment. You also have describe, so you can also, instead of just doing kubectl describe deployment, you could do kubectl describe pods, and you would get the same information uh, about that pod. So if we run that command, we see that we have our name for the deployment, the namespace it's operating in, creation timestamp, labels, annotations, selectors, replicas, and a bunch of different information. So let's look for the replicas field showing our desired. So we have one desired, we have one updated. It also says we have one total, one available, and 0 unavailable. Let's look for the pod template. So over here, each pod is going to get labeled with app equals nginx deployment. For our container, we have the image using nginx, and then we didn't specify any ports or environments, mounts, volumes, or none of that. So let's get the pod name. Let's just copy that real quick. Or actually, so this command right here is us just setting our pod name to this variable. So it is using kubectl get pods and finding that pod using the label. And we're getting an output of JSON, and we're just parsing through it and saving it to the pod name. So let's run this. And that is our pod. Let's actually just double verify, or let's verify it. So yep, ends in W6Q9H. So we can also view logs from our nginx pod using this command. So kubectl logs, and then specify your pod name. This is also good for debugging as well. Uh, so this just shows a list of events that happen within that pod. We don't see much because there's no requests that have been made. And then let's actually try executing a command inside the running pod. So we're trying to get into the interactive shell of a specific pod. And then we're trying to see what version of Nginx it is running. So everything after these two hyphens is the command you're actually putting inside that container. So we got our version of Nginx 1.29.5. Now let's edit our deployment. So again, this just opens up your default code editor where you can modify things like your desired amount of replicas. So let's find, you can also change the image. So let's find the line with image. So this is specifying the image that our containers are using, Nginx. And then let's actually try changing that. So we're going to change it to use Nginx version 1.16, and we will save and exit. And then this command is we're just checking to see our pods again. Uh, again, there's really not a lot of things going on in the background. So that's why it's being created fast. So if had an application running inside this pod, it would probably take longer, and we'd be able to uh see the update happen. So notice how our pod name from before is different to the new pod. That's because we updated that image. So let's press Control C just to exit out of there. Let's get our replica set. So this was our original replica set, and then now this is our new one. And it matches our new pod as well. Notice also our old pod has all zeros, so we're not even using it at all. Or our old replica set. Now let's create a MongoDB deployment. So we're creating a deployment with a name, Mongo deployment, and using the image Mongo instead of Nginx. So our deployment got created. Let's verify. We have the Nginx deployment and the Mongo deployment now. So this is not ready yet, but let's try running it again. So now we see it is ready and available to use. So let me just clear my screen real quick, make it neater. Let's list all the pods. So we have the pod for the Mongo deployment as well as the Nginx deployment. We're running the same command that we did earlier, but this time using the Mongo pod, and we're just trying to see the version. So we're running 8.2.5. For cleanup, we just do kubectl delete deployment and then specify the deployment name. Let's get deployments and pods. So now we only have the Nginx deployments and Nginx deployment pods as well. Now let's actually delete our Nginx deployment and verify everything got deleted. So no resources, so that's good. Now let's actually create a manifest file. So let me create a new directory called lab. CD into it, and just go ahead and open it up. All right. So first thing we're doing is creating a replica set. So we're going to run that real quick in the terminal. We'll get a file created called nginx replica set, and let's just quickly go over it. So we have our API version, and again, remember this just shoot. So lines 1 through 6 is just specifying the metadata of our replica set. So we have the name of nginx replica set, and then we label it as app nginx replicas. We then get into our spec. So this right here is specifying that we want 3 pods, and we want those pods to have the label of nginx server, or we're looking for those pods to we're looking for pods that have the label of nginx server. Below that is where we specify what labels we want for the pods. So app nginx server, and again, these two have to be the same so that the replica set can reach the pod. And then we're just specifying the container configuration. So name nginx, we want the nginx image, and we want port 80. So the manifest will create 3 identical nginx pods, and they're going to be labeled with nginx server. So let's go ahead and actually create everything. In order to do that, we do kubectl apply, and then we specify the file, nginx replicaset.yaml. So it got created. Let's get our replica set. So nginx replica set got created. 3 are ready. Now let's get our pods. So we do have those 3 pods, so that's good to go, and they're all running. Now let's try filtering the pods by label. So we should get all 3 back. Let's go ahead and test self-healing. So let's try deleting a pod to see what happens. Right here. We're just specifying, we're getting our first pod and setting it to the variable pod to delete in this first command. So let's go ahead and run it. Let's verify that we have something set to our variable. So we got the one that ends with KFKLR. Let's check our pods again. So yep, it got the first one. So now let's try deleting it. It says it got deleted. And then let's get the pods again. So notice that the KFKLR got deleted and got switched out with a new pod that says that ends with RxKSZ, while the other two pods remain. So that is the replica set in motion. So it's we must always have three pods based on this manifest file. Let's go ahead and delete this replica set. You just run kubectl delete and specify the file name. Let's try getting our pods, no pods. Get replica set, no replica set. Now let's actually create an Nginx deployment. So we have a new file that got created called nginx deployment.yaml. It has the same pattern and format as before. So we specified that this is a deployment file. We name it nginx deployment, and we label this deployment app nginx dep. Then we're specifying our replica set configuration. So we want two pods at all times. And we're looking for the pods with the labels nginx via dep. We specify that we want our pods created to have the label app nginx via dep. And then we specify our container configuration. So we have the name nginx, and then we're specifying the image and the ports. So port 80. So let's apply this deployment. Let's check for that deployment. So we have two pods, and they're both available. Let's check for the replica set with the label of nginx via dep. And here it is. Let's check for our pods with the label app equals nginx via dep. And here they are. So notice how we have two pods as we specified again. Now let's try creating a node port service manifest. So let's create our service file. So over here, we have the metadata for our service. We specify our selector. So again, this selector allows us to connect back to our deployment so that it can reach our pods. And then we're specifying the service type, node port, our protocol, our port, target port, and node port. So let's go create the service. Let's get services. Now, rather just having the Kubernetes service, we now have the Nginx service as well. We see the type, node port, cluster IP, external IP, and the ports. So this right here shows that port 80 inside the cluster maps to port 30,003 on each node. Let's describe this service to get more information. So let's look for the endpoints. So this shows the IP addresses of our two Nginx pod, and the service will load balanced traffic across those two endpoints or pods. So now let's access it within a URL. So, so notice when we ran this command, it gave us a URL. I just clicked on it and we see our Nginx page over here. So that's working. Now let's try this other command. So minikube service Nginx will also just automatically open it up on your browser. But I have another screen, so it opened up on that one. So next thing we're going to do is to scale up our replicas to 4 from 2. So our command for that is kubectl scale deployment. We specify the deployment name and we throw in this flag replicas and set it to 4. So let's try kubectl get pods. Let's see if we have 4 pods now. And we do. We have 2 with the age of 10 seconds, which means these just got added on while we kept the previous 2. Let's check our endpoints again when we describe our service. We should have 4 endpoints, 1, 2, 3, and then 4. Let's scale it back down. We're running the same command, but changing the replicas from 4 to 2. Let's check our pods. And we still have our original pods here. For cleanup, to delete our service, we run kubectl delete, specify the file name. For deployment, it's the same thing. Kubectl delete, specify our deployment file. So let's press enter. Let's do get all. Let's do kubectl get deployment. Let's do kubectl get service. And looks like we're good. Let's check one more. Let's do kubectl get pods. All right. So understanding the application structure, again, let's break down each component. For deployment, it's the highest level controller, declares desired state. So image, replicas, labels, and manages rolling updates. It also creates and manages replica sets. Replica set ensures the specified number of pod replicas are running. It's created automatically by deployments, rarely created directly in production. Pod, the actual running container, or containers created and managed by replica sets. It's ephemeral, so it can be deleted and recreated at any time. Service provides stable network access to pods, uses label selectors to find target pods. And then types include cluster IP, so it's just internal, allows your pods to communicate with one another. Node port allows external traffic, and then load balancer. Labels, key value pairs that connect resources together. Selectors use labels to find matching resources. Critical for services to discover pods. Again, labels just allows everything to connect together. Manifest files is the YAML files declaring desired state, and you apply it with kubectl apply -f, version controllable and reproducible. We have some troubleshooting steps. So what we've built today, we've created a Kubernetes application stack that deploys containers using both CLI commands and manifest files, maintains desired pod count automatically with replica sets, self-heals when pods fail or are deleted, performs rolling updates with zero downtime, exposes applications externally via node port services, load balances traffic across multiple pod replicas, and scales up and down on demand. So I get to go through everything again. The key important terms: deployments, services, replica set, service types, and let's see if I'm missing something. And your ports. Are there any questions? Let me stop sharing and stop recording.